Okay. I'm not even sharing the screen. Wow. Okay. Alright, so I just wanted to tell you after this particular part that there are certain examples basically of collision that we need to understand. So, first, we're going to look at that examples of collision, and we'll also try to understand what is exactly happening so that if it comes in the exam, we should not be confused. So, first of all, let's talk about when a bomb goes off. Okay, so if a bomb goes off, which means it's like this and sticking, so this is the ground. Okay, so right now we should understand that because its speed is 0, so the momentum before is also 0. Is it clear?
Yes.
Okay, so if the bomb goes off, so of course all the bomb particles really spread in each direction, right? So some go here, some go here, right? Like that. So the point is, because the momentum is a vector quantity, when you add all the sum, so total momentum after would also be 0. So the point is that at this point you should remember, never ever think the law is like not being followed. The law will always be followed. You just need to give the justification that's a vector quantity. So if the momentum here goes with certain momentum here, so there's another particle that would be going at the same momentum and this and this. So when you add all the momentum, it should come out to be 0. Then the other thing is, let's suppose you might have seen those people hanging on the circus, like in the circus they hang. So suppose they're like hanging and holding hands. So right now their momentum is 0, but when they release themselves, so basically one would basically go, copy this. When they release, they basically he will move here, he will move here. So if its momentum is mv, so its momentum will be minus mv because the vectors, when you add them up, the momentum will still be 0. Is it clear? Any questions? Okay. Finally, the last thing would be rockets. For rockets, you just need to remember that before the rocket is fired, so looks like this. So the momentum is 0, but when it's fired, so the rocket also throws out, the gases are expelled from here, which means that if the body of the rocket has a momentum mv, the gas will also have mv, but in the opposite direction. This is for body, it's for gas. So when you add them up, the total momentum afterwards should also be zero. Is it clear? So never ever think that momentum before and after can be wrong, unless it's not an isolated system, right? Alright, now let's look at some type of collisions, right? So now this is very important, but in fact, before we go to type of collisions, I just want to do a little bit of derivation, and that's the relationship between kinetic energy and momentum. So this derivation is included in the course, and they might also ask you to do it. So let's see this. So what we've learned previously is that the kinetic energy is equal to half mv square, and the momentum we just learned that it is mass times velocity. Everybody agrees? So suppose I write this as KE equals to, or let's write just EK so that I have the smaller symbol, equals to half mv squared, then this will be P equals to mv. Now the only thing that you see common in both of them is mv and mv, but there is mv square and this is mv. So what we're going to do is we make v the subject. If I make v the subject, I can write it as P upon m, and then I can simply put it right here. So if I do that, then EK will be equal to half m P upon m whole squared. This will be half m P square over m square. Now m and m square will cancel out. That would leave us with P square over 2m. And that's the relationship between kinetic energy and momentum. Any questions, please? Let me know. Okay. Ahmed, how are you?
Sir, I'm fine.
Ahmed, why am I seeing you for the first time? Were you there last class?
Yes, sir, last class में था.
Okay. Alright, but I don't know you. Okay, Javeria and Khatija. This is very bad habit to come late to the class, you know. Now, is there any question? Should I go on? Alright, so now we'll discuss the types of collisions. So basically collisions are categorized in two types. Number one is elastic and the other one is inelastic. Now, when we talk about elastic collision, it means that an elastic collision, okay, in an elastic collision, doesn't make sense. The total kinetic energy before the collision is equal to total kinetic energy after the collision. So basically the principal equation is, let's suppose you have one object going with velocity u1, this is m1. There's another object m2 u2, and this is what is happening before and afterwards. This goes at v1, this goes at m1, v2, m2, right? Now, so basically elastic collision means that if I take half m u1 square plus half m u2 square, it would be elastic if it's equal to half m v1 square plus half m v2 square, which means basically there's no other conversion. So after the collision, the same amount of kinetic energy has transferred to each other, and there's no loss really. But in an inelastic collision, the total kinetic energy before the collision is equal to the total kinetic is not equal to the total kinetic energy after the collision, which means is that if this is the same situation, in fact I'm going to put this in the center because we want to look at it as it is right here. So for this one it would be like this, like half m u1 square plus half m2 u2 square is basically not equal to half m v1 square plus half m2 v2 square. So m1 m2 m1 m2. Is it clear, everybody? Any questions, please let me know. Okay, Ahmed, Aman, Safir, Javeria.
No questions, sir.
Okay,
No,
now
sir.
so
No, sir, it's clear.
what we can do is we can actually make a summary out of it so you guys know exactly what is happening here. So whenever these questions come, you need to basically look at three different things: kinetic energy, you need to look at total energy, and you need to look at momentum. So, and I'll basically put the same for the other one. Oh. So for this one, you need to understand that kinetic energy is always conserved, which means it is the same before and after. Total energy is conserved and momentum is also conserved. However, in the inelastic one, this is not conserved, which means that some of the energy is gone to other types, but total energy is the law, and that is that you cannot just create or destroy energy, right? It can be changed to other forms, so it is always conserved, and momentum is also always conserved. So only kinetic energy changes, you need to remember that. Okay, now so I just want to basically tell you, let's do one example so that we can actually understand this. In fact, I'll just put this so that you guys don't forget. Okay. Alright, now let's do an example. So, suppose there is an object going at 3.0 meters per second. There is an object which is at rest. Its velocity, its mass is 2 kg. It is 1 kg. And basically, they say after collision, both bodies stick together. The moment you basically see this word stick together, or combine or embed or whatever, I just want to give you a note here. This condition is always inelastic, no matter what. If they say if it's elastic, you always say it is inelastic because it is. Okay, now first they ask prove that the collision, so they're always going to do that, is inelastic. We already know. And then afterwards in the second one they say calculate the kinetic energy transformed into other forms. Okay, now let's do this. Ouch. So the biggest issue is that we don't know what exactly was the speed afterwards, right? So we're gonna say that afterwards they just stick together and they were moving at a certain velocity. So this is 2 kg and this is 1 kg. And this is the same condition. This is the condition 2 we learned previously. So if you don't remember, you got to go back. Now, what you're gonna do is make the momentum equation first. So m1 u1 plus m2 u2. Let me change the color, please. Equals to m1 v1 plus m2 v2. So m1 is 2. It was going at 3. This was 0 because it had no velocity. Now when they stick, so we got to add the masses and multiply with just one single velocity because it has one single. So 2, 3, 6. This is 3. So the velocity is going to be 2.0 meters per second. Now, with that said, we need to prove that it is inelastic. So we got to make the equation half m u1 square plus half m2 u2 square equals to half m1 v1 square plus half m2 v2 square. So for the first one I'm going to write half, that's 2, that's 3, 0. This whole will be 0 because it was at rest. Then afterwards, basically what you're going to do is you're going to add the masses, so 2 plus 1, and then velocity square would be, we just found velocity to be 2, so 2 square. Now this is going to be 9, and that's going to be 3, and 2, that's going to be 6. Because 6 is not equal to 9, so we're going to say okay, hence kinetic energy is not conserved, so it is inelastic. Is it clear, everybody? Any questions? Okay.
Yes, sir.
Now they say how much energy is lost. So we know that kinetic energy before should be equal to kinetic energy after plus the one that is lost, right? So kinetic energy before was 9 joules, after it was 6 joules because this is before, this is after, plus lost. So basically you lost about 3 joules of kinetic energy. So that's pretty simple, right? Okay. Please look at this. If you don't understand, please let me know. Now, Now these are the type of questions that require this big equation, but then there will be certain questions which do not require a big equation. So what you're going to do is, that particular thing is called the relative speed of approach and relative speed of separation. Okay, now let's look at it. Now I'm not going to, basically it has a big derivation behind it. There's a formula that you need to remember. Okay, but it's up to you really. You can always ask me to do that derivation after the class. I will be happy to. So but the essential thing is to remember the equation. So the equation is u1 minus u2 equals to v2 minus v1. So this is basically the equation, but how I remember this is, like, I just keep u1 and v1 together and u2 and v2 together. That makes it easy because I know that I have to add both of them on one side, and before and after and before and after. Is it clear, everybody? Any questions? So it's up to you. It's really up to you, right? What you're gonna do. So the point of this equation is that basically it does not have mass, and it can do things faster for you. So if it is elastic collision, so for elastic collision, you need to understand that this u1 minus u2 equals to v2 minus v1 is actually equal to each other. But if it is inelastic, on both hand side they will be like u1 minus u2 will not be equal to v2 minus v1. Is it clear, everybody? Okay. Now let's look at the type of questions, okay, that they're going to be. And in paper one, they will actually try to trap you, and please don't get trapped. So I'm going to show you two types of questions which will help you understand what you're looking for, right? Well, I'll write type 1 question. So for type 1 question, suppose they have given you x, they have given you y, they say this is like moving at 50 meters per second, this is 30 meters per second. They have not talked about the mass or anything. They might be equal, whatever. And then they have they say which row is possible for two masses after collision, and they do not say they stick or whatever. It's not given, right? So after 10 minutes you guys need to rejoin. Now what you're going to do is just need to understand that here they have given a table, this table, and you will have velocity x, velocity y, so that's afterwards. And for part A they've given it as 0, 20, then B 10 and 10, and they've also given the direction. So this is towards this is towards this, and this is also towards this. Now see, zero, okay. Now the thing is, in these sort of questions, I just want to tell you that it is completely doable with this equation. That's the kinetic energy one, but it will take ages to do it. So what you're gonna do is you're gonna write the equation. So say u1 minus u2 equals to v1 minus v2. And generally, it is considered that you take right side as positive, left side as negative. It is not, something that you should always follow. I mean, you can take right as negative as well. So, which makes okay, if this was 50 and this was 30, and this was moving in this direction. So, I would call this positive. I will call this negative. I will call this as positive. This as positive. Positive, negative, negative, positive. Zero has no direction. Is it clear, everybody? Sorry. So I have kept u1 minus u2 equals to v1 minus v2. Now, so initially u1, let's write plus 50. u2 was basically minus 30. So you have to be very aware of the signs. Always use the correct ones. And then what you're going to do, so all this side will always be the same, but this one, this is 0 minus 20, because minus you're subtracting, so plus 20, like this. Is it clear, everybody?
Yes, sir.
If you notice on the left side, it will be positive 80, but on the right side it will be negative 20, because they do not match. It means, oh, which row is possible to masses of, I did not write it completely, for an elastic collision. So we're basically looking at an elastic collision here. So because the velocities are not the same, so I'm gonna simply, cross this out. This is not the option, and then I'm gonna check the other one. So these basically stay the same, but afterwards it's plus 10 minus plus 10, so that's gonna be 0. So plus 80 equals to 0, so that is wrong as well. Then plus 50 minus 30, this one is minus 20 minus 0. So if you add them, so plus 80 and minus 20, that's also wrong, aren't possible. And then for this one, plus 50 minus 30, so this is going to be minus 30, and that's going to be minus plus 50. Is it clear, everybody?
Yes, sir.
Okay, so if you go through that, then you realize that they're basically equal, which means that this is the correct answer. Is it clear, everybody?
Yes, sir.
So make sure you always get the right answer. But why I prefer the other method is, I mean, this equation, because it makes it simpler for me, because then it's all in the plus, so I can just put negative and negative. That's simple. Like for example, if we do it for that, from that we can also attain the same result. But okay, we'll do it for the next one. Okay. Now, so the next type 2 question that I want to show you, and this is very interesting. You guys need to be very, very aware of it. So some questions, paper 1 will take a lot of time, and because they take a lot of time, we got to be careful with that. I actually wrote it wrong. Sorry, this is v2 minus v1, so I wrote it wrong. Sorry, but still the answer is still the same. Never mind. Wait a second, please. Plus 20 minus 0. Plus 10 minus 10. Oh, plus 10. 0 and minus 20, and this is 50 minus 30, so it will be the same anyway. So type 2 questions include, suppose there is a mass x which is going at a velocity v, and there's another mass y which is stationary, so its initial velocity is 0. Okay, now they say the spheres collide with, elastically what could be the possible values of velocities afterwards. Okay, so they actually give it to you. So I'm gonna copy the same table. Oh my god, it doesn't get copied. Wait. Now they have different options. It would look the same to you, but it will be very different. I'll tell you why. So for x, they have given like half v to this direction, y also half v to this direction, then here v this direction, and this is 0. They've given half v to this direction and half v to this direction. It says 0 and this says v in this direction. Is it clear, everybody?
Yes.
Now what you're gonna do is, okay, after I think 1 minute you guys need to rejoin the same link. Okay, now first of all assign the directions. So you say, okay, I'm gonna take positive on this side, negative on this side. Well, you can switch also. So positive, and this will be positive, this will be positive, negative, negative, positive, positive. So I put the directions and now I write the equation. u1 minus u2 equals to v2 minus v1, like that. Now u1 was basically v, and this was 0, and here this would be half v minus half v. So if you add them, basically on one side you get v equals to 0, which means this is the wrong answer. Is it clear? Just like we have done before. Okay, now let's do the next one. In fact, let the meeting close and then when you rejoin, because this is very important. Okay. questions, please. 1 minute, in fact. Okay, now, so what you're going to do is, for the next one, we write the same thing. V minus 0. Now V2 is 0, and that's minus V. If you check out the answer, it will be V on that side and V on that side. The biggest rookie mistake is, although this seems to be the correct answer, but the biggest rookie mistake is most of you will actually make mark B as the answer. But that would be wrong, because now write a note here. No matter what, always check all the answers in any question. Is it clear, everybody? Always check all the answers in these type of questions. Aman, Safir, Khatija,
Yes, sir. Got it.
do not forget about it. Now, what you're going to do next? Check the next one. Let's say this one. So V minus 0. It's half V minus half V. So if you add half V with half V, it is still giving you the same answer. So it could also be the correct answer. Then for the next one, V minus 0, and this will be V minus 0. So this is also V equals to V. Now if you have multiple correct answers, right, so what you should do is, let me write next note. When faced with multiple correct answers, use momentum conservation to be sure. Okay, now let's try this. So what you're going to do is write m1 u1 plus m2 u2 equals to m1 v1 plus m2 v2. So this has mass m, this is mass m. So what you're going to do is, initially all your equations here for the first one, for part A, so we are skipping part A because it's already wrong, so you don't need to check it. For part B, it will be m times v plus 0. So this will be the same on the every single step that you want to do, but this will be m times 0 plus m times minus v. So if you check, the answer here would be mv equals to minus mv. So this is not conserved, which means this answer is wrong. Momentum must also always conserve. That's what I've told you, before as well. So now check C. This will be the same because the condition is same. For C, it is going to be m times minus half v plus m times plus half v. So if you add them up, this is going to be mv equals to 0, which is also wrong because momentum should be conserved. So automatically we know it's d, but let's just see how it's d. mv plus 0. So this is going to be m times v plus m times 0. So this only gives us mv equals to mv, and that would be the correct answer. Is it clear, everybody? Now, although these type of questions will take some time, and usually underneath these type of questions they will also give you a lot of space, so you should always remember that something is fishy that they have given you that space, right? And do not stop at just one answer. Please don't check everything. Is it clear, everybody? If you have any questions, please let me know now. So tomorrow, what you're gonna do is we're gonna just complete this chapter for two-dimensional momentum, and then I'm gonna give you a very specific worksheet to practice. If you do that, I'll check it, and hopefully I'll see that if you guys have understood this chapter or not. All right. So I believe I'm gonna